Unit 18, part 13. Okay, so Klenk goes through an example for you on page 351 to 352, basically. So read through her example. I'll do a different one. I'm going to do 3L from the exercises at the end, page 354, 3L. And here is the premise and the conclusion. I will say is an F, right? So A is an F or B is an F. F here is a one-place predicate, so that's an appropriate mode of expression, right? If one-place predicates are for things that hold of one individual, right? For the two-place predicate, which here is G, right? I will say something like, so G x y, I will say x g's y, right? Or if it's G, A, B, the formula G, big G, little a, little b, I will say A, G's, B, okay? Because I'm going to be translating this, and you should keep an eye on the meaning, or be also processing for meaning to make sure you get the translations right. But look at the way it goes. Okay, so this is how you answer the question when presented with this in exam. So this is what you're given in the exam. One or more premises, one or more conclusions, with quantifier formulas, either actually in quantifier form as these are, or as mixed statements, right? So it could be that a premise or a conclusion, or the conclusion is a, as I said before, a conjunction with quantifier statements as parts, or subformulas, or a disjunction, or whatever, with quantifier statements as parts. Then you keep that form, the truth functional form, in place, and you just translate the quantifier statements. But here, okay, these are both so this is a universal statement, is a quantifier statement. Always start with the leftmost formula, right? Because this says what? This says, okay, so I'm processing it for meaning with things I said before. I'll say x is an F, x, geez. Okay, it says, for all x, if x is F, then x, there is some y that x g's. For all x, if x is F, then there exists some y that x g's. There exists a y such that x stands in the relation of g to that y. X is g-ing y as well. Okay, so what does that become? Okay, this is how you answer. First step, specify your domain. I recommend, so the advice from before carries over. Sorry, to go back to the definition of validity thing, right? So because an argument in relational logic, which is more sophisticated predicate logic, it's monadic predicate logic. Sorry, it's polyadic predicate logic. Because validity in predicate logic in general, monadic and polyadic, many place, two place, three place, because validity in predicate logic means there are no counterexamples in any domain. What does that mean? It means if you look for a counterexample in a domain and you find that it is impossible to assign truth values to the atoms such that the premises come out true and the conclusion false, that is, if it turns out that it's impossible, if there are no counterexamples in this domain, you are not allowed to infer that the argument is in fact valid. Remember back to the arguments for unit 16. I put up the argument for modus ponens, or the argument form for modus ponens, P hook, Q, therefore Q, or was it modus tollens? Anyway, and I said, let's try to assign truth values to them, to these formulas that make the premises true and the conclusion false. Very quickly we realized it was impossible, which is exactly what we want for a valid argument form, right? That valid argument form is one that doesn't have counterexamples. But as soon as we grasped that assignment failed, right? If you make the first premise true, you can't make the second one true without failing to make the conclusion false, right? When we saw that assignment was impossible, we could immediately infer that the argument is valid. Can't do that when you're just working it out for a specific domain for quantifier logic, because just because there are no counterexamples in, say, a domain of 2 individuals, doesn't mean there are no counterexamples in domains of 3 or 4 or 5 individuals. So what that means for you doing an exam is start with a domain of 2 individuals, try and find a counterexample. If it fails, if you can't find a counterexample with a domain of 2 individuals, move to a domain of 3 individuals and try to find a counterexample. If you can't, hint for the exam, you've made a mistake. The argument that will ask you to prove an argument invalid in relational predicate logic will be an invalid argument, and you will be able to find a counterexample in a domain in either 2 or 3, either 2 individuals or a domain of 3 individuals. So if you can't find one in a domain of 3 individuals, technically you should go into a domain of 4 individuals, but I say try again. All right, so here's how the translations go. So for all x, so it's saying this is true of everything. Step 1, specify the domain. Domain equals notation A, comma B, right? Step 2, rewrite all the formulas, all the premises in conclusion, to state what they mean in this domain. So for every x, if it is f, then there is a y such that the x g's y. Okay, so what it means to say that's true of all of them. That's true of A and that's true of B. The result of this will be a conjunction. If it's true that if A is f, then there exists a y such that A g's y. Okay, see that? If it's true of all of them, well, I'm going to run through all of them. A, B. So it's true of A that if A is f, then there is some y that A g's. And also it's true of B. So also, if B is f, then there is a y, right? We keep this quantifier such that G, B, y, such that B stands in the relation of, sorry, is that horrible? It's G, B, y. Kind of important. G, B, y, like that. Okay, that's a conjunction. So notice what happens now. This is truth functional form. Because it was a universal statement, it's now a conjunction. But look, I still have two quantifier statements that I must rewrite, okay? I'm resolving all the quantifier formulas to truth functional formulas. They must all be resolved from quantifier statements to truth functional formulas for the semantic method to become possible, right? For me to be able to assign truth values to the parts in a way which then determines the truth value of the formulas as a whole, right? Determines, think back to truth functionality, right? You've got to have it all resolved into truth functional form such that assignment of truth values to the parts determines the truth values of the formulas themselves. Why is it the case that if I have it all resolved into truth functional form, that an assignment of truth value to the parts determines the truth value of the formulas? Because if it's all resolved into truth functional form, that means hooks and dots and wedges only, those formulas are all truth functional. The truth value of those formulas is determined by the truth value of the atoms, right? So got to resolve get rid of all the quantifiers to make this semantic method of proving an argument invalid possible. So I'm going to get rid of this. So but the overall form remains in place, okay? That's the important bit. It remains a conjunction, right? It remains a conjunction, but it's going to be a conjunction, right? That's the left conjunct still, that's the right conjunct, but they get expanded such that it's FA hook, right? This is what's getting expanded. And what does this say? There is some y such that A G's y. What does that mean in a domain of two individuals? It means either A G's A or A G's B, right? If A is F, so what does this conjunct say? It says if A is F, then A G's something. Well, there's only two things in this domain of two individuals. So if A is F, then A G's itself or it G's B. Yes, processing for meaning, those are equivalent. Okay, and similarly here. So this will, okay, and notice that this conjunct was a conditional and remains a conditional. You don't mess around with the truth functional form of the thing. You only replace the quantifier statements with truth functional interpretations of them. Not interpretation, like you're making it up, like you determined what the interpretation is, given the domain, given how many individuals there are, okay? Okay, so FB, what does it say? If B is F, then B G's something. Then there's something that B G's, so it's still going to be FB hook, right? That part of the form remains in place, but this becomes a disjunction, right? There is some Y such that B G's Y becomes the disjunction G either B's A or G B's itself. Close bracket, that goes with that, right? That's the major operator. All right, come back and do the conclusion.